So I'm Paul Megan. I'm the Chief Architect for the Networking BU here at Avaya.
I'm John Mead. I'm in engineering responsible for our access products.
And we have Aaron here off to the keyboard just on the side. He's actually going to do all the real work in the background when we do the demos. We're going to walk through a few things here. We're going to start a little high level. I was told I had to use slides. I don't normally like using slides. So I'm going to walk through just general concepts, SDN, fabrics, make sure everyone's caught up on what we mean by those terms. And then we're going to walk into a demo to demonstrate exactly what we mean by those terms. So we're going to try and stay away from vaporware and actually talk about reality as well. If you don't know who I am as well, besides being the Chief Architect here, I also co-authored Shortest Path Bridging with several other amazing engineers out in the industry from several companies. I've worked in MPLS and the ITF for 14, 15 years now, dating myself a bit there. So there's a long history of networking. And as Alan said, we have the second most deployed Ethernet ports out there. And if you don't realize that, it's because Avaya acquired the entire Nortel switching business. All right, so that's where that comes from. So a lot of experience, a lot of engineers, a lot of these guys in the room have a lot of names on our badges through the years while sitting at the same desk, right, which is very common here in the Valley. So I do want to jump in here and have a conversation about what we're going to do with SDN. Before I get there, I do want us to talk about one other thing. When we talked about the Olympics and what we did at the Olympics and how we did on a single protocol, there were a lot of lessons that we learned there, as well as lessons we've learned in all the other deployments of fabrics we've seen around the world in almost every single vertical. And one thing I kind of just joke about is the Internet of Things is a pain in the ass. All right? It's going to be one of the biggest explosions and tsunami waves of connected devices coming at us that we've seen ever. And the problem is that it's not just wired, it's wireless too. We have an amazing deployment at a very large auto manufacturer. And a large amount of their environment are wireless tools to build those cars. At the same time, they've got people walking around the manufacturing floor with wireless tablets and phones and laptops, and the robots are wired connected. So in their world, and one of the things they have a problem with is the idea that we're going to manage two separate networks has to go away. All right, so why am I using a wireless controller that at best gets a 10 gigabit throughput and tens of thousands of dollars going over terabit switches that cost me a fraction of that? So let's kind of step into this thing. Where this came from is complexity. Engineering as an aspect, if we looked at the evolution of where engineering comes, we always tend to solve problems by adding layers. You can look at any problem we've done over the last 20, 30 years in engineering. In MPLS, we had labels. We had still stack labels. In wireless, we create a virtual network over a physical network to deal with the fact that routing protocols don't like IP addresses moving around. All right? That's a big problem in the old school kind of way of looking at things. So we had to basically work on a way to make the network more dynamic. The issue comes back then to what I was just saying there. If we keep adding more and more complexity, we introduce too many touch points, too many complex issues, too many problems are actually create for performance to the end user. So as we care considerably about what the user experience is, contact center, for example, the vast majority of those agents are wireless. The vast majority of UC users are wireless. They're soft clients. There are a lot of different ways you can think about what real-time is. Additionally, in healthcare, who are also using fabrics, a doctor's idea of what real-time is, he wants to see the radiological data. He wants to see it on his iPad while he's walking across the hospital in a video session with another doctor. This isn't futuristic Star Trek anymore. This is the world it is today in these environments. So that's real-time to him because the radiological data is far more important to him than anything else. So if he's getting his radiological data and it's gigabits of image and he's only on 802.11n, guess what his performance is like? All right? In the past, he was trapped at his desktop because he's downloading radiological data to his desktop, and no doctor wants to be trapped at their desktop to look at this stuff. Again, they want to roam. This is going to help alleviate with 802.11ac, but the problem then becomes is it's still a virtual network. And if I'm being bottlenecked by controllers and tunnels, it's still going to affect the performance from his perspective. This complexity has to go away. So from our perspective is that we are moving towards what we call a unified network. The wireless and the wired devices sit on the actual native LAN. The same port that you're plugged into with the PC is the same port that the AP and VLAN are on. So that when I'm on my tablet and I pick it up from my desktop and I walk across the campus, I'm not in a tunnel. There are no more tunnels in our solution. There's no tunnels between APs unless you've got an IP network in the middle. You put a fabric in the middle, there are no tunnels needed. Because the fabric itself is going to remove all the complexities that were required to put the tunnels there in the past. It makes the network actually more dynamic. right? It actually integrates the routing, the switching, and the virtualized routing that we do. And we demonstrated that at the Olympics as well. So when we think about what SDN is, this has been a fun thing for me over the last few years working in standards as well as working with customers and working with delegates like yourself, is SDN means something different to everybody at every moment. Right? I could probably ask every single person in this room alone what an SDN is, and you'll give me a different answer each time. I walk across different vendors. They're each going to give me a different answer about what an SDN is. Some are going to say OpenFlow. Some are going to say VXLAN. Some are going to say NVRE. If you've followed in the ITF, you might say GeneV, right? And then the question you have to step back is, when I ask CIOs, the first question they ask is, what is this giving me that my network today doesn't already do? Why am I going to spend an entire budget on upgrading to get the same functionality, or worse, what I'm seeing in the industry, less functionality than what I have today? So when we step back and say, what's really the point, what's been the driver behind SDN? It's really about automation. Every time you actually look at everyone's definition, if you peel back and push back the noise, it's about automating the configuration and the deployment of devices and applications. So if that's the sense, then we look at this list, which is a list from one of those environments, not ours. It says what they're trying to address with SDN. Now, if you went down this list, network complexity, of course, is the biggest bold thing on the top. And we come at it from the perspective of networking. I definitely do. You're going to hear me talk from a network perspective, not from the wireless end, because that's my background. All right? But the network complexity, like we talked about in the Olympics, and if you watched the tech field day we did before, we showed how there was no complexity in the network anymore when you're running a fabric. You just configure the edges. There's no configuring the core. There's no stacked protocols fighting for time. It's one protocol that sees all the routing switching all at once, and it just reconverges around 50 milliseconds in the environment. Applications can't even see a failure happen. So crawling down this thing, deploying new applications, virtualizing the network. We've got mobility. That's an interesting statement there. For years, we've been dealing with the fact that mobility in data centers. I'm not sure how many of you are familiar with the way virtual machines move around, but you're probably going to agree with this definition. A VM moving from one rack to another has to move on a LAN, keep an IP address, and keep its MAC address. Does that sound familiar? That's wireless. It's the same exact problem set, except the number of devices are different. Even the operating system base is the same. Unix and Windows. Right? A Mac is a Unix, basically. So if that's the same problem set, and we've already solved this in the data center, why can't we reuse the same solution everywhere else? And that's a different perspective too from Avaya. We look at a problem set in the network not being a data center problem. It's a network-wide problem. And we want to also create these virtual networks so that they exist from the end device plugged into the campus to the end server virtual machine sitting in the data center. So when they plug in an MRI in a hospital, it's got a private network all the way back to the server back in the data center. When you're roaming around in the doctor SSID, you're in a private network back to the servers, also in that private network back in the data center. If you're teachers and students, the same thing. Everything's isolated on a per basis. And we're extending that virtualization out across the wireless RAN as well. All right. So just a background quick on SPB requests. 3 things I usually like to try and explain real fast for people trying to catch up. I've got to describe something that would normally take me a day to walk through how it works in less than 15 minutes. 4 things are actually right there. The first one I don't usually talk about scale. If you ever need for more than 16 million services, we need to talk. All right? So these 16 million services are what we use instead of VLANs. There are still VLANs on the edge to attach, but now we have something we call an ISID. This was invented over 8 years ago. It's been deployed around the world. It's a concept basically extending. It was invented in 802.1 AH. Now we have this ISID concept that allows us to actually really do a VPN, not a virtual topology like VLANs do. So instead of 4,000 VLANs, we have 16 million services. Those services can be both layer 2 and layer 3. And we can use layer 2 with layer 3. So in all these environments that they were talking about, they actually use ISIDs as their virtual networks. And it's not just stretching a LAN across the environment. That would be idiotic. It's about connecting the LAN where it needs to be to a virtualized layer 3 service as well where it needs to be. So you do your routing and switching at the most optimal points in the environment. Additionally, on top of that is the flexibility. Now we're able to actually use what we call VRFs to do that virtualized routing. We're able to do layer 2 VSNs, a layer 2 virtual service network, stretched anywhere we want to use mobility. This is what we do in data centers right now. At the Olympics, we had 6 data centers. Every virtual machine thought it was one switch router they were connected to. When we move a VM from one end of the Olympic Village to the far end of the Olympic Village to the other data center, it thinks it went in port 1 and out port 2 of the same switch. It kept its IP, it kept its MAC, completely unaware of the fact it just went through a multiple terabit core to get there. It went through a multiple terabit core. It wasn't bottlenecked by tunnels. Now we reapply that to wireless, and this is what we're going to talk about now. So the last thing here I want to talk about is security. Inherent into this protocol, because it was designed for carriers, military, enterprise, all the environments that Ethan has deployed, and it's deployed in a lot more environments than campuses and data centers. It's deployed inside refrigerators and cars all over the place. So security in this environment is pretty important. In PPB, we did a lot of work for carriers. When we did SPB, we took it another step further. So now you have security in the isolation of services because of those ISIDs. That's true isolation of a service. But the other thing is that the network disappears. When you do a ping or trace route, when you're on one of these fabrics, the network's one hop. You can't see anything underneath. You try and hack sitting in a wireless network, you know, little Billy visiting grandma in a hospital, he only sees the hop out to the internet. He went through 50 switch routers to get there, but he has no idea that that's what he went through. Same thing with the doctors, it doesn't matter. Now from an IT perspective, you see more of that environment than you ever did in a traditional OSPF environment. You're actually able to say, show me the path that it's going to take from this switch to that internet gateway, and it'll give you right there either in CLI or through a GUI and highlight the path it's going to take. You put a sniffer right on one of those links, you're going to see the actual packets. You will never send packets where they don't belong, and you'll always replicate multicasts at the most optimal points. Integrated routing, switching everything together, one state machine. All right. So one thing I leave you with from this before we get into the demos in FA is, in the traditional world, we have multiple tiers, multiple protocols, spanning tree, OSPF, PIM. You want to do virtualized routing? Welcome to MPLS, LDP, BGP, VRFs, right? And you got to touch every single point in this environment to make sure that they're all there, all right? That means 80% of the time we've noticed out there is just keeping the lights on, trying to tune the network constantly. That world's going away. That's the point of SDN. The point of SDN is stop tuning everything every day. So when we get to a fabric-based world, it's already doing that in the core. We don't tune everything in the middle of the network. We just turn the protocol on. We never touch the core. What we do then is we just configure where we want to service on the edge. And the network automatically detects that and connects those endpoints together within a couple of milliseconds. It's actually really cool to watch when you turn up a layer 2 VSN or a layer 2 VSN here. Maybe it's a VM that appeared that caused it to do that because it's all automated. Or it's a wireless user who happened to walk into this building and that VSN didn't exist before. And now it's there just because they're there, right? That's a nice thing when you think about that. So that basically means you don't worry about tuning the network every day. You simply just orchestrate the network. All right. So what we're going to get into this thing is talk about how we're going to do some services. And I want to define a service real fast. This is actually a very high-level view of what we did at the Olympics. We had a core and we had edges. So you saw we had competition venues and a lot of competition venues. This is like the luge. This is where you had the ice skating rink or whatever a venue might have been. And we had the data centers over on the right. By the way, when you're watching the video, we were providing that video. We were also looping the video back into a private VRF and multicasting it out to every single venue, every hotel. 1,500 set-top boxes were streaming all the channels of every event in this same converged network, while we're also doing video surveillance, while we're also doing the timing. What those colored icons are those different virtual networks, the routed and switched environments. So the little squares here are the virtual switch. You see light blue and red and light blue and red. Those are two virtual LANs that were stretched between environments. The light blue and red routing icons here, those are the virtual routers that were running there, the VRFs. So we had optimized routing and optimized switching in every layer. We extend this concept. This could be guest wireless, employee wireless, doctor wireless, extend it out. Wired and wired, same virtual LAN. Roaming, native hardware switching, no tunnels. So the next thing we're talking about is how we're going to make that even simpler when you plug in an AP. Because we want to extend this right out to the wireless environment. We want to make the AP essentially nothing more than a virtual bridge. It is a true switch. It's like an SFP. It extends the wireless LAN. It connects it with the native LAN using native Ethernet technologies. So we get to that point, but we also want to make it you just plug and play. You just ship it out there, plug it in, it automatically does all the configuration using an SDN technique to do it. All right? So from this, I'm going to hand off to John, and he'll actually give you the real demo instead of me pontificating here.
Thanks, Paul. Appreciate it. All right, I'm going to go into some of the details of Fabric Attach. Paul did a good intro on our Fabric Connect technology. In Fabric Connect, it delivers you a zero-touch core. You touch the edges of your core, but you do not have to configure the middle of the core. So Fabric Attach, what that does, it extends the Fabric Connect core all the way out to the edge. So what Fabric Attach does is it gives you that zero-touch edge. That's the one message I want you to leave with today, zero-touch edge. So Zero Touch Edge, what does it do for you? It gives you the ability to add devices to your network, move devices in your network, change devices in your network. You can do all that with zero touch or zero configuration of the edge. Think about wireless LAN today with controllers and the trend of moving from wireless LAN controllers to controllerless environments. With a controller today, all the traffic from the AP is tunneled back to that central controller, and it's just blindly tunneled back to that controller. The controller will then do the work, the data plane, the control plane of how to get that traffic across your network. Without a controller, in a controllerless environment, now it is important to make sure that the infrastructure, your switches, are configured correctly. So auto attach is even more important now that you do have to do more manual configuration of the switches. Okay, let's talk about the key elements of Fabric Attach. Referring to this diagram here, we have our Fabric Connect core that Paul talked about. Now, on the edges of that Fabric Connect core, we have our switches, and in the Fabric Attach world, we call those switches Fabric Attach server switches, okay? Now, connecting into that Fabric Attach server switch, it's optional. You don't need this Fabric Attach client switch, but it is an option. So anyway, it's another Fabric Attach switch that's at the very edge of your network where you're going to actually plug in your clients. And then finally, you have your end devices themselves, wireless LAN access points. We call them Fabric Attach clients or Fabric Attach APs. Moving back to the core, we also have a Fabric Attach policy server. That policy server is going to be used to authenticate and authorize these devices, wireless LAN access points that are plugged into your network. And pulling all those different elements together is what we call FA signaling. So as this process goes on, these various elements need to communicate with each other. So we have FA signaling for these devices to communicate to one another. All right, moving on. I'm going to talk to you a little bit about how it actually works. So before Fabric Attach takes off, you have your base network, you have your base setup. So in this picture here, we have our Fabric Attach core. It's been configured. At some point in time, the network architect, the network administrator builds this Fabric Connect core. In that core, there's various services that have been set up. In this picture here, we have a virtual service network for management, for employees, for guests, and for IoT. Those are the Internet of Things, many actual devices. So this is our core network, and this is the base setup. In addition to the base setup of the core network, you also maybe have some edge switches plugged into that core network. That's also a component of our Fabric Attach environment. So this is the base setup. Fabric Attach hasn't started yet. So the trigger point when Fabric Attach gets involved is when you connect that edge device. Okay, so that's the first step. You physically plug in your device. And what happens next is the discovery of that device. So we've discovered that device. We know what switch that device was connected into. We also know what port that device was plugged into. Okay, so that's the first step. The second step, yes?
What is we?
Avaya. The user.
It's the Fabric Attach technology. When I say discovery, is that what you're... I'm asking the question. What is that we? Is it a protocol? Is it an appliance someplace? I mean, you say we do this, what's we?
Yeah, okay. Good question. All right, so a couple different cases. Devices can be discovered, devices that are of type FA clients. So an FA client versus a standard client. An FA client is a part of our FA environment. So it has the ability to do FA signaling, so to communicate that data up to the switch. So that can trigger discovery. Another type of discovery mechanism is if the device is being authenticated, or if it's an 802.1x in the AP supplicant. So the switch will detect that device, and then it will talk to our Radius server, in our case our IDE engines, our access control device, and that's how we can discover that device in that case. So a couple different mechanisms.
And with the FA client, is that an agent that's running on the machine?
Yes, it is.
Okay.
Yep.
Not the end device, the switch or the AP.
Yeah, so
You were saying an FA client. Are you referring to an AP as a client at that point?
No, that's their FA is to the edge, not to the end device.
Exactly.
Yeah.
It's a signaling protocol to the device that we're using as a network edge. The AP is now the network edge instead of a virtual network over the physical network. The clients get authenticated using identity engines, wireless or wired. right, using .1x techniques the way they always have. Okay. So you don't have to install a client on the, a software on the client. That's what we're trying to make sure we didn't imply.
And how are you authenticating the FA clients? Right, because you're talking about this whole thing being zero touch. Well, I know zero touch can be really bad.
There's a SHA 256 built into as well as a two-factor authentication built in from that policy server and the device. So security was number one concern when we started this thing, make sure someone couldn't just grab an AP and suddenly hack into a network. Right?
Yeah. Was there a connection with the former Cajun hardware?
No connection at all. This is all the evolution from the Nortel environment. There is no Cajun in this anywhere. Completely different team. In fact, the building you're in used to be the Nortel building. Okay. Did you go on, Don?
Okay, thank you. So step one, discover the device. Step two, authenticate the device. Is this device allowed on the network? Yes or no? If it's not allowed on the network, depending on the policy that's been set up, you can block the port, you can allow the device, but put them on a guest network. The policy is pretty flexible. Step three is then to authorize that device to be on one or more services. So in this case, this device is going to be authorized to be a member of our management virtual service network, or it can be a member of one or more, and I'll go through that in a minute. So after the device is authorized for a service, then we have the configuration information that needs to be provisioned on the FA switches. So we have our edge switch here, we're calling that the FA client switch, and then we have the switch that's at the edge of our Fabric Connect core. We call that the FA server switch. Anyway, there's provisioning information that needs to be performed on those two switches. So using FA signaling, that data, and that data it requires VLAN information, and with our Fabric Connect core, it also requires ISID information. So a VLAN is bound to an ISID. That information using FA signaling is passed to your FA client switch. The FA client switch, again using FA signaling, passes that information to its upstream switch, which is at the edge of the Fabric Connect core. So on those two switches, this configuration data is automatically provisioned. Okay, so backing up just a little bit, you have our base core setup. Fabric Attach is triggered and starts when you plug in a device. And everything that happens after you physically plug in that device is all automated. The device is discovered, authenticated, authorized, and then the switches are then automatically provisioned to allow that device on the desired services. So that's the base of, that's how Fabric Attach works. Let me go through a couple examples with you. Here's an example. Let's say we're going to add an access point to an existing network. So this example applies to adding one access point. It applies to adding 50 access points or a couple hundred access points. It doesn't matter. It's the same example. What I want to show you is that you can add 100 access points in your network, and it's very easy. Before I talk about how it works with Avaya's unified network, let's talk about how it works in a traditional network. Okay. So in a traditional network, you have your wireless management station or your wireless controller. Wireless controllers are on their way out, but in this traditional legacy network, you sit down at your wireless management station and you build the configuration for this access point that you're going to add. Now you can plug in your access point in this traditional network, but the access point won't have connectivity to the network yet. You do have to go out to that edge switch and configure that, create that VLAN. Maybe the VLAN's already been created, but you do have to add the port membership for the port that you plug the access port into. So it is important to know what port in the traditional network. It's important to know which port you're going to plug that access point into. Now in this example, we could be doing 100 access points. So you're not touching just one edge switch, you're touching many, many edge switches. So after you finish with the manual configuration of your switches, you're good to go. You're ready to go. You plug in your access point, and this configuration is, the access point will be discovered by your wireless network management system, and the configuration is pushed down to that access point, and everything's good to go. Everything's working fine. Unless during that manual configuration you made some type of configuration mistake, or maybe you plugged the access point in the wrong port. But you fix those small minor issues and everything's working fine. Okay, now with Avaya's unified network, how does it work? So with Fabric Attach, the first step is the same. You do have to build this config for your new access point. So on your wireless management system, we call this our wireless orchestration system. We'll build the configuration for this access point that we're going to add, or access points that we're going to add. The next step, using Avaya's unified network, is to push that configuration down to the access point. So once the access point gets that configuration, there is no need to manually configure the intermediate switches. Once that access point gets that configuration data, using FA signaling, it will signal that up to the FA switch. And from a security point of view, what we talked about earlier, that signaling is protected by, we use SHA-256 with a key, a configurable key on both ends. So once the FA client switch sees that configuration data, it needs to pass that up to the FA server switch. And there is some checking to go on, making sure that this is valid data and there's no conflict. And once that check happens, there will be auto provisioning on these two switches. And then voila, you're good to go. Your access point is on the desired network and a part of the desired services. So with Avaya's Fabric Attach, you do have to manually build the config on your wireless management station. You push that config out, and then everything else happens automatically.
Quick question before
Sure.
you advance. Just to put this in the context of the greater SDN world and evolution, this is very proprietary, right? I mean, this is Avaya, and it's only Avaya, and you're not going to put anything else in, and it's not going to play with any other solution. This is Avaya.
No, that's not true. We actually announced the signaling into the IETF 2 weeks ago. The draft is actually public right now. We're actively talking to other vendors out there to actually integrate this into their systems, so that way they can take advantage of the signaling too. We want this to be open. We're backers of OpenStack. We're backers of Open Daylight. We're backers of all open standards.
So, but as far as products you can go lay your hands on today that you can lay down money for, this is an Avaya solution end to end.
Right now, because it's the first release of it, we put it into our products first.
All right.
Over the coming years, as other vendors integrate it, right, they'll be able to do it too. In the meantime, that's what the wired devices see over here. They'll get the same benefit of these virtual networks extending down through the wired switch, through wired connections, and then they automatically get the benefit of wireless if they use our APs, of course.
But the FA concept, I guess it's the first time I'm hearing it.
Mm-hmm.
The FA thing attached to like SDN. It's not a mainstream SDN term?
Not yet, no. Because we looked at it it came basically out of this discussion with a lot of CIOs. When I kind of hit it at it when I was talking about SDN. What does SDN really do? I've had several CIOs say to me personally, I don't understand what OpenFlow actually really does for me. It seems like a bunch of academics talking, because he thought he was talking to me as an academic. Yeah. And so when we take that poll of the industry looking around, the reality of what we heard from almost everywhere we went in the world was, that doesn't solve any of my problems. What we need is to automate this edge. We've got AC coming, we've got Wave 2 coming, we've got AD coming, 11 AD, right? Every time we do this, that's another layer of access points. It's more access points every time. I've got Internet of Things coming, so help me automate that. And that's where they're kind of driving. That's also the reason why we aren't trying to make it proprietary. We want to go to the other vendors who make MRIs and go make these light bulbs that have IP addresses and all the other combinations of things that are coming at us, right? But first phase, it has to start somewhere. All right, so where are we going?
Yep. Okay.
Make sure we get to the next presentation too.
This is all that's important right here. Moving on to the second example. Okay, second example, what is this? Consider a network that already exists. It's a network that's been configured with multiple services. Same diagram. It's a network that consists of many APs already. You're not rolling out new APs. In this example, what you want to roll out is a new service or a new policy. As an example, we have this employee virtual service network that already exists. Let's say we want to split that up into two services. So wireless clients will still be attaching to the employee SSID. However, that employee SSID will map to one of two services. So the AP has the ability to detect this, map it into two different VLANs. Those two different VLANs will be mapped to two different services. So let's take the example, employees that are using company-sanctioned devices, that could be one service. Employees that are using their own personal device, that could be a second service. Those two different services have different access privileges and so on. The AP can detect if the employee is coming in on a personal iPad or if it's coming in on a company-sanctioned device. The AP will then, from that SSID, the AP then can send it up into the network on one of two different VLANs. So let's say we want to roll out that service. You can roll out that service today in an existing traditional network, or you can roll out that service with Fabric Attach. With a traditional network, what do you need to do? Okay, you need to build and create this new policy, this new service on your wireless management station. Step number one. And you can push that config out to your access points, but it won't become effective until you manually configure your networking infrastructure, the switches in your network. This new service, let's say it's a new VLAN. You have to go to all the switches in your network and create that VLAN on those switches. You also have to create the right port membership of where those access points are actually plugged in. Those ports have to be a member of that VLAN, that new service. So after that manual configuration, this new policy can take effect, and it's going to work fine. You might have a few mistakes in your configuration. You can fix those. You will discover those and fix them. But you may misconfigure a port. Should have done port 40 instead of 39 or whatever. But you can fix all that. It works. A little bit of pain associated with it, but it does work. In Avaya's unified network with Fabric Attach, what do? First step is the same. You have to build and configure that new policy. You push that new policy out to your access points, and you're done. You don't have to manually configure these switches. It's the same as example 1. So this access point, it's using FA signaling. It will signal up this new service. That switch at the edge, the Fabric Attach client switch, will receive that data. It will signal that up to the Fabric Attach server, and the auto provisioning will take place. So you're done. Everything's automated after you push out that new config. Okay, that's example number 2. Example number 3 is probably the coolest of all, so I'm going to let Paul talk about it. But it really talks a lot about how we remove the need for tunnels in your network and that problem that everyone's worried about of what do you do about L3 roaming? It's not a problem with Fabric Connect. Thanks, Paul.
This also gives us an opportunity to boot up a switch and get an AP out of a box kind of thing in the background. So ignore the man behind the curtain as we start going through this. In a second, as we move towards the demo. Big thing I want to talk about here is going back to that no tunnel thing. So as we're plugging in these APs going to the demo, I just want to put in a forefront of your mind again. If you think about what's going on the left here is a typical campus. You have core, aggregation and edge, and you have the access points, all right, being plugged in. In the past, of course, you have tunnels going between the APs to a controller, or maybe you have tunnels going directly between the APs. And our APs will do that as well if you're not running a Fabric and you have a traditional IP network. You can use the tunnels between them. But when you use the Fabric, this concept on the right is what logically is created even in any of those models. But what's nice about it is when you get into this thing using the Fabric, it's physically this representation, both wired and wireless. So in the blue being, dark purple here being the employee and the light blue being the opposite, it's kind of interesting how the wires and wires will be plugged natively into that switch into that native VLAN. So what you're going to see in the demo here is we're going to walk through that. When you see the switch automatically being plugged in, that's the wired environment. The switch gets out of the box, shows up site, you plug it in, it automatically gets this configuration. Oh, you want to deploy the access point next? Pull it out of the box, plug it in, it automatically extends the wireless over VLAN into those same things. So from that, I'm going to hand it off here to John and Aaron. I'll let them kind of switch this over.
Thanks, Paul.
Yep.
All right, we've been talking a lot about Fabric Attach, Fabric Connect. It actually does work, and demos always work the first time, right? So we're going to show this to you now and walk through it step by step. So here is the starting point. This is our Fabric Connect core. We have our Fabric Attach server switches at the edge. And this core has been configured. This is a Fabric Connect core. So what we're going to show over here is the console port. This upper window here is the console port of this Fabric Attach server switch. So let's look at the configuration of that switch. And what I'm going to show you is a before and after. Before, this is the configuration, and after, automatically, without us doing anything, there's new configuration on that switch. So the base configuration of this switch, which is necessary to be a member of the Fabric Connect core, is as follows. So we showed the VLANs. So we have 4 VLANs created. VLAN number 1 is the default VLAN of the box. Everything's fine. We have created a management VLAN. That's management VLAN number 10. Thanks, Aaron. So you see, it is the management VLAN. Also note, it's not a member. No ports are a member of that management VLAN yet. Okay. We also have 2 other unusual VLANs here, VLAN 1000 and 1001, and these are unique for our SPB environment, for our Fabric Connect core. These are the backbone VLANs and are necessary to be a member of this Fabric Connect core. Okay, so this is the base setup. from a VLAN configuration point of view. So now let's talk about the services that have been created on this box. We have created one service already, pre-configured before the demo. So we've pre-configured our management service. So this management service, the ISIT is 10,000, which is bound to a VLAN of 10. That means any traffic flowing into this box on VLAN 10 is bound to this service 10,000. And if there's other members in your core also on 10,000, it can talk with those devices. So this is the base configuration. Give me a build on that. Okay, so now let's talk about this edge switch. Imagine this switch being out in the wiring closet. So we've brought that edge switch here. This is our edge switch, the FA client switch. It's not connected to the network yet, and I want to show you the base configuration of this switch. What is the base configuration switch? Well, it does have a VLAN configured on this box. VLAN number 1, it's the default VLAN. You'll also note that this VLAN number 1, it's also the management VLAN of this defaulted box, okay?
Can that switch be any Avaya switch?
Okay, so this fabric attach technology, we have to have implemented it on that switch. So fabric attach is a software module that's running on that switch.
And any Avaya switch ever built will run this?
Every Avaya switch
will run it. Not
yeah.
Will run it.
Will run it. So it's in several products right now. It's being mapped out to all the others as we speak.
Yeah, thanks, Paul.
Okay, sorry.
Absolutely. We're putting in as many products as we can. We have some legacy switches that are shipping. They're going to be end of life. We will not put it in those boxes. But every switch from this point forward, just to elaborate a little more, our edge switches and our core switches will have this technology. Okay. What are we showing here? Okay, so now this defaulted box has not been connected to the core yet, does not have an IP address either. So management VLAN is stuck on the default VLAN number 1 and no IP address yet. So let's go ahead and connect the two boxes together, if I can do this without messing up. Okay, so this is a drop from our core. It's coming from the FA server switch. Can't remember what port, but we'll find that out in a second. I'm going to plug this in here. Plugging it into port 48. Sorry, can't see. So we now have the connection. Now let's see what's happened to our configuration. Okay, the VLAN configuration. Before, only VLAN 1 was created. So let me back up a second here. Fabric attach is about plugging in edge devices. I haven't plugged in any edge devices. So what's happening here? Well, fabric attach does start taking place when these two switches are connected. There's a discovery that happens there. During that discovery, important information is passed back and forth. One thing that's passed back and forth that you can see is the management VLAN. It's important for that edge switch to know what VLAN he should be on for management purposes.
Is that like LLDP discovery, just a straight up standards-based neighbor discovery,
Yeah,
or is
it's
that
based on LLDP discovery?
Smart guy.
Okay.
So our FA signaling uses various standard protocols to communicate between the different elements of fabric attach. Between the two switches, LLDP is one protocol that we have leveraged to communicate this. So some proprietary TLVs have been implemented. Okay, VLAN 10 has been created. Also, VLAN 10 is now a port of 48, member of 48. So 48 is the port we've connected to. And also, another thing that happens, now this feature can be enabled or disabled. Some customers won't like this, so you can enable or disable it. We have it enabled. So this client switch will also when it gets that management VLAN, that triggers a DHCP for him to go out and get an IP address. So we plugged in this switch. We haven't configured anything, and that switch is now reachable by the network administrator. You can telnet into the switch and do additional configuration or do whatever you'd like. But just simply plugging it in is what caused this to happen. So we haven't really talked about fabric attach yet. That's the magic happens when you plug in the actual edge device. So we've shown the default configuration of the server switch, the client switch, and now we want to plug in a device. So we have an access point.
So there's probably a little bit more too with security. I'm sure no one can just bring an Avaya switch into your environment and kind of plug it in and start getting management VLANs.
Yeah, let's talk about that. Paul mentioned that earlier, and in this FA signaling, we do use SHA-256 with a key that can be changed if the customer wants to.
So there's like initial configuration on the device before you send it.
If you don't have the right key on the AP, it's not going to connect to the network. Right there.
And I keep talking about this base configuration. So can I need to come clean here, right? So can I take this switch clean out of the box with zero config and have all this work? pretty dang close. There's one or two things that need to be pre-configured, and we're going to resolve that in our next release coming up in January. But yeah, you virtually don't have to configure anything. For example, there is a default key. That's one thing the customer is going to want to change.
Right.
That yeah. Okay.
We assume people want to configure that key so someone just can't buy a switch
That's
and
what
plug
I'm
it into the network.
Yeah.
Cool. Yeah. Okay. So you're unboxing that AP over there?
Okay, where was I? I lost my clicker.
Put the AP on.
Oh, here we go. Okay, so this AP user documentation, very important to read this, right? I read it last night, so I'm good to go. Right, we all do that, right? Okay, here's the access point. Now, this access point is powered by Power over Ethernet, so when I plug it in, it's going to take a few seconds to boot up. So I talked a lot about how you can plug your access point into any port, and that's because it doesn't matter. The discovery process will tell us what port it's in. So I can plug it into any port. To prove that, does someone yell out a port number, your favorite number?
32.
32, sorry. 32 actually doesn't work. Can you pick an... Oh, I'm just kidding. 32.
58.
Oh.
Well played. Well played.
58. Who said that? Troublemaker. Okay, it's only a 48 port switch, so... Okay, so I just plugged in the access point. It is powering on, it's booting. So let's back up a second. So what do we have? We have our base network. This is our Fabric Connect core. It's using our SPB technology that Paul talked a lot. Fabric Connect core, zero touch. So now we have our zero touch edge, which we're going to try to prove right now. So zero touch edge, zero touch core. We're plugging in an access point, no configuration. Make sure Aaron's not typing anything over there. The access point should have booted by now. Let's go ahead and look at some of the on our client switch, this edge switch. Let's look at some of the results. Okay, we need to wait a little bit longer. I got it.
So
okay.
while we're waiting, the FA access point has the FA agent added to it in order to make this self-discovery process
That's correct.
work.
It doesn't have to, right? We support clients that don't have that special agent, and in that case, we would rely on something like 802.1x to authenticate that device.
But that would be, are you saying 802.1x for the AP?
No. So all the traditional AP management systems that exist are there. They exist inside the system as well. So like if you're plugging this into an environment that's not a Fabric core, right? And it's just a traditional IP network, you're going to have to configure all the traditional styles. You're going to have to pre-provision it. You're going to have to do the tunnels between the APs. And what we all know is wireless for the last few years and where everyone else in the industry is going with wireless because there's an IP core there. When we're trying to show is make sure that you realize that we kind of approach this a new way where we're trying to do wireless plus wired fabric can get you a whole lot more and a lot easier way of deploying it and what we're seeing in live deployments.
Well, my question, the reason I asked the question is you'd hinted this is open, and I'm not sure how open is, but if you could put a different vendor's AP here if it had an FA agent on it.
Oh, if it had an FA agent and you configured it into your orchestration suite, right, it will participate. That's the point of an open standard. So that's all. It is LLD paced. We did that on purpose too.
Well, but so is 811S. So is we had this conversation yesterday. F, right? You know, there are open.
So that was
standards
how open
are open standards,
right?
and
but
you know what?
How useful is that if nobody?
Let me take off my Avaya hat and put my IEEE hat on for a second. This is the one thing that's actually kind of interesting about when you're going to see things change over the few years about this is in Ethernet in the switches, everything works together. Buy a switch from any vendor, they all plug in, they all just work. In wireless, we haven't been able to do that, have we? This is where we're hoping we're leading the industry to. Because that really does need to start happening.
Somebody's got to step up. So if you're saying you're stepping up.
We're trying to step up and say, guys, we got to get to this industry. We can't keep locking people into proprietary extensions for this.
That's dangerous. I mean, you know, it is locked, right?
Yeah.
Totally agree with that. But that's a dangerous statement. You know, everybody has different technology. I mean, can you imagine interweaving 2 or 3 vendor APs and have issues? Who do you call?
So right now, you interleave 5 or 6. I know of some networks have 10 different vendors doing the physical switches. Who do they call? They've been doing that for 20 years in networking. So it's already precedence concept.
Well, I have to be honest. I don't know a lot of customers that do that. Usually they...
Not in wireless. Yeah,
I'm talking in general, though. I mean,
so the wired guys in the room, do you disagree with what I said?
In what statement?
Anybody who's a wired, more networking wire guy? Andy, you're kind of shaking your head. Yes, I'm kind of... It's a mixture. There are some customers out there, sure, they buy one vendor. I know a lot of customers that buy multiple.
Blend in whatever they can afford or have still running.
So let's take an extreme case, right? Let's say you're going to buy a wired device and it's a video camera and it doesn't have an FA agent in it. We can get all this to work with that device. We can discover that device using our 802.1x. We can discover it using something simple like MAC address authentication. But once we've discovered that device, if there's been a policy configured for that device, then he's allowed on the network, and that policy will dictate what service he needs to be on. So you buy a bunch of video cameras. Let's say you buy 200 video cameras. You don't want to have to manually configure all the switches that you plug these video cameras into, right? So you plug them in, gets automatically discovered, automatically authenticated, automatically authorized for a service. Let's say it's your video surveillance service, and voila, the switches are automatically configured, and you're done. You're good to go. That's another extreme case. Now you get a much more powerful and flexible solution if those edge devices are FA clients, so they have that agent embedded in it.
So
but we're really trying to push a unified environment here, where we support wired and wireless.
So that's the problem, and I guess the biggest analog to this would be in the voice world. I don't know if you guys know anything about voice or not, but SIP is the exact same problem. So we can create an industry standard protocol that we can push down to any kind of endpoint. However, your experience with that endpoint is going to be significantly degraded if it's not a device that comes from your company, and I've dealt with that before, where getting simple things like call waiting to work on SIP is an undertaking because it all has to be standardized. Whereas, well, if I just use that skinny kind of protocol, everything works magically, and that's fine. So you guys are saying that we'll support non-SPB endpoints.
I already do. It's just Ethernet. It's just IP.
Right. But if you want it to work right,
this is the interesting thing.
SPB.
We got a dichotomy of there are certain protocols that need a whole lot of special attention. There's other protocols that don't. SPB, OSPF, spanning tree. They all just work across all vendors. We've been doing that for years. SIP, a few others. Wireless has seen this as past. They need special attention, and oftentimes vendors try and do proprietary extensions to lock you in. It's not an all or nothing kind of thing. There's a wide spectrum of these protocols that we've seen over the last few years. And do I like the fact that they lock it in as a standards member? No, I don't. As a standards member, that's why I'm trying to drive a more open perspective.
So that's actually a discussion that's been going on with Mike Fratto for just a couple minutes. So you're saying that FA, is it based on SPB or is it SPB?
No, it's based on LLDP.
Okay.
All right. That's a very important aspect, is that it's just Ethernet. It's simply just simple TLV saying, I've got a VLAN, I want it to attach to SISAID, please do it. And
those TLVs are published somewhere that
they are absolutely published right now. They're published on the ITF right now.
So if I go out, I roll my own switch, or I roll my own AP. If I implement LLDP and I implement those TLVs, I can self-provision through this?
You could. Yep. Absolutely.
Well, but there's I guess I still don't necessarily agree with the sort of the panacea of, hey, you're going to have wireless APs from a couple of different vendors hanging out in your infrastructure. There's so much more that goes in the wireless space, from roaming in between vendors, authenticate, sharing keys between vendors, solutions. I mean, there's just.
But there's got to be a first step. Quite honestly.
Yeah, the first step was CapWAP. And 802.11s, right?
I see a lot of chuckling in the back of the room at that one.
Well, I mean, it's true, right? So I mean, here we are. Well, let's try it again. It didn't work the first time, so let's make it yet another standard, right?
Yeah, and this is more about trying to get us down to the real wire. For us, it's more about getting it right onto the wire itself. And yes, there's CapWAP, and the RIP support CapWAP too, and all that wonderful capability for when you don't have the fabric. It's just trying to get us down to just simplify the deployments, make our users' lives easier to deploy these things. Because if it's not getting easier, it's just going to get exponentially worse as we go through these generations.
So I guess I see. So you see this being a hopped up version of things like smart ports.
I think it's even more than that, because it's not simply going to be a lock-in too, but it's more about making life easier. I don't know any other way to say it. Just plug it in and go.
Okay. So we can call it. Somebody would come up with white box APs.
White box APs. Technically, you could do that. Absolutely. It'd be one of the things we're working on in the background is putting this in open LLDP. To the question you asked earlier, if it's an open LLDP, guess what you could do?
I mean, from that perspective, though, so you can make it all connect, but what does management feel like? I mean, you still have
The orchestration suite. In fact, actually, that's why I'm trying to move this on, because there's another demo that goes into that management suite that's after this, and we're running out of time for that. We'll see that.
There is a third section. We're going to go into the details of the wireless LAN portfolio. So I'm going to wrap up this demo right now. So just backing up, where are we right now? We just plugged in this edge device, this wireless LAN access point. We hope to see that it will have SSIDs that will be advertised, that will be mapped to these services, okay? So we plugged in the access point. Thanks, Aaron. So we've showed the VLANs on this edge switch. Before, we only had VLAN number 1 and VLAN number 10. Now, you see the automation that has happened. We have automatically created 3 additional VLANs, and this was all triggered as a result of just plugging in that access point. 3 VLANs on the right ports. So obviously they have to be on port 32, which is the access port where the access port is plugged in. Access point is plugged in. Also, it has to be on the uplink port number 48. Okay, let's look at this is the FA server switch, which is the switch on the core of our Fabric Connect core. We're going to show the VLANs on this box. Same thing, the existing VLANs are still there. Now we have new VLANs, VLAN 20, VLAN 30, and VLAN 40. Those are the VLANs associated with these new services. We're going to show the services now. When we showed the services before we plugged in the access point, we did have one service that was service 10,000, which was the management service. You now see that we have 3 additional services that have been created, 20,000, 30,000, and 40,000, which do map to the VLANs 20, 30, and 40. So the auto provisioning did actually happen and work. It happened on the FA client switch and the FA server switch. What else is there to show?
Can I ask where the policy actually lives at? Like, is the policy living on a box in the...
Yeah. See those green arrows going up to the right to that identity engine server?
Okay. So that's actually where the network policy lives?
Yeah. And in that case, the FA signaling is based on 802.1x protocol.
So the intent there is still centralize manage it, but push the config down out as well. All right. So we don't want you going out and configuring 1,000 APs and, when wave 2 and AD come out, maybe it's 1,500 or 2,000 APs. You configure one place and you just plug the APs in wherever they need to. You also don't have to worry about sending 2 people out to configure a switch and AP and, make sure you put in port 10. No, just here's an AP and plug it in and it goes.
But didn't you say we have to set a key on the AP in order for it to trigger all this?
No, not in the AP, because the AP is going to be put into private, and the orchestration suite takes control of it and sends down what it needs to signal.
So if I really wanted to, I could trash somebody's network by going and buying a bunch of Avaya APs.
So let me restate that again so you hear what I was saying. The AP has no config on it. We're going to configure it with its key, because when we detect it, we're going to see it, and we're going to put in that management one, make sure that it's the actual right AP, it's AP we want, because it's already been configured up in that orchestration suite. If that AP hasn't been configured up in that orchestration suite yet, it doesn't connect to the network.
So I've got to put in the MAC address or something up in the orchestration suite to block it.
Exactly. So that's the one thing that's different
to allow it.
Earlier you stated that we had to put the key on the AP.
That was the switch. His question was about the switch.
You included it. You did include the AP in there. So
okay, we should have been more clear about that then. Yeah, the AP is slightly different because we don't want to expect someone to CLI into every AP before it goes out there. So that is the step you would do it up on the orchestration suite.
Okay.
Right.
Okay, wrapping up the demo. We're taking more than our fair share of time here. Wrapping up the demo, the access point has been plugged in. The switches have been auto-provisioned. You should see this this access point advertising these new SSIDs. Should be called FA Demo or FA Guest, something like that. If you try to connect, you can connect, but this is the demo network. You won't have access to the internet. Just to summarize, Fabric Attach, what does it do for you? It provides a zero-touch edge. That is an extension of Fabric Connect from the core. Fabric Connect gives you a zero-touch core. So now you do have zero-touch infrastructure for adding, moving, or changing devices on your network.